Okay, so welcome back. We're going to do section 1.2 today, which is displaying quantitative data with graphs. And our learning objectives are we are going to construct and interpret dot plots, stem plots, and histograms, describe the shape of a distribution, compare distributions, and use histograms wisely. So when you describe the overall distribution, you should comment on these 4 things. The shape, so where is the highest point? Is there a highest point? Is it going to be skewed right, skewed left? Do you have 2 highest points? So what's the overall shape looking like? The center, so the median and the mean, and this needs to be a value. So you're going to give a numerical answer. What is the mean? What is that? And you'll choose one or the other, and we'll discuss that later, which one. So then the spread. So here you can do the IQR, the interquartile range, the range, or the standard deviation. Now within spread, you should also always comment on the variance. So is one more spread out than the other? And then if there are any outliers or data that do not fit the general pattern. So when you're describing shape, you can look for either symmetry or skewedness. So here, what I kind of always do is draw a little curve over your dot plot here. And here you can see it's roughly symmetric, not quite exact, but roughly. And then here, when I draw this guy, so you can see this guy has all the little ones over here on the left. So these have the little guys. And over here, these have the big guys. And the way I think about it is if you're doing a tug of war, and you guys are going to laugh at this, okay, but if you're in a little tug of war match over with the little guys or the big guys, well, these little guys, they're so little, they're going to be screwed. Or you could think that they are skewed. So here you could say the left-hand side is the screwed, i.e. skewed side. All right, so you can stop your laughing now. All right, so here, when you see this last one, you got the little guys over here on the right and the big guys over here on the left. So which side is screwed or which side is skewed? Well, that would be the right side. Laugh as you may, hopefully it helps you remember. So here, again, if it's roughly symmetric, then it's going to be a bell shape. Uniform, so if they're all nice and even with each other, then this is uniform. U-shaped, so here you can see it goes up higher at the ends and you kind of got a U shape going on. Bimodal, so as you draw, you have 2 distinct peaks, so that's going to be your bimodal. Again, skewed right or skewed left. So over here is the little guys, so it is skewed right. And over here is the little guys, so it is skewed left. And the skewedness, why it's called skewed right and skewed left, is because these little guys, instead of your mode's always going to be at your highest point, but your median and your mean, they get pulled towards the skew. And we'll discuss that in more detail, but that's mainly what it's talking about. So you could always use stuff to put in your calculator. You can go to the list, so you can go stat, edit list 1, and enter all your data. You could sort either ascending order or descending order. So if you wanted to then organize all that in the list, you could go stat, edit, sort, and you could look at your list and make your dot plot. So that's a little bit easier once you have all your data in order first. All right, so here I have a lot of data. So let's go ahead and enter this on our computer. Sorry, on our calculator. Yikes. All right, so I just pulled up my little calculator here, and we're going to enter all of this data into the calculator. All right, so I'm going to go stat, edit, And in list 1, if you have anything in your list, you can come up here, hit the clear button, and it will clear out your list. All right, clear enter. So let's put all that data in. So 3, 0, 2, 7, and keep going. So I'm going to let you keep going. And once you have it all in there, I'm going to go back to my home screen. You can pause while you're getting it in there. You can go stat, and then we're going to sort ascending, and we're going to go second, list 1. So now when I go back and look at my list, I can see that my data is in order. And again, I didn't put everything in there. But now that you have your data in order, you can make your box plot. Your dot plot. My goodness, Mr. Rose. All right, so we can make our dot plot. And here it looks something like this. So here you can see that this would be a little bit skewed to the right, possibly a little bit bimodal. This is spread out definitely, so it's got some variance going on. You could say what your range would be, so you could do 8 minus 0. We could find lots of stuff, but right now we just see the dot plot. Comparing distributions, so here looking at these we can discuss the shape, the center, the spread, outliers, and again always comment on that variance when you're doing the spread as well. So here I want to compare the distributions of household size for these two countries. So I'll let you see if you can determine what you want to do. You can pause me and then we'll talk about them. Alright, so here South Africa is definitely skewed to the right. The UK is fairly symmetric. The center for South Africa is going to be greater, so the center is going to get pulled over here with the skew more. So I don't know, the center might be around in here. We could calculate that a little bit more if we wanted to. But it's roughly pulled over more, whereas the center is probably somewhere around here in the UK. So if we wanted to find that center, since we have skews going on, then we can find the median. So if you wanted to find the median, you could find the middle number. And for South Africa, it ends up being 4. Or sorry, for UK, it's 4, and South Africa is 7. Sorry about that. So over here and over here. Okay. So South Africa has a higher center. The UK spread is smaller, so this is a lot more spread out. It has a lot more variance. This is all tight together, so it has a lot less variance. For the spread, you might also comment on the range here, or you could do the interquartile range if you wanted to find that. So here the range for South Africa is your highest minus your lowest, and that's going to give me 22. For the UK, I'm going to do my highest minus my lowest, and I get 4. And I can see that this guy is definitely going to be an outlier for South Africa. This one might also possibly be an outlier, but you definitely have at least one outlier. And in the UK, you do not have any. All right, stem and leaf plots, another way to spread the data, to display the data. So how to make a stem plot. So you're going to separate each observation into a stem and leaf. So the stem is all but the final digit. So you can have multiple digits on the stem, but the leaf you're only going to have one digit. Write all possible stems from the smallest to the largest in a vertical column and draw a vertical line to the right of this column. Write each leaf in the row to the right of its stem, and you're going to put those in ascending order. Arrange the leaves in ascending order. And then always provide a key that explains what the stems and leaves represent. So here's just an example. Here you can see I put all of these guys in. So you only want the final digits to be in the leaves. So this was already in ascending order. So as I start, I can have my stems be my 1, 2, 3, and 4. And my leaves here would be 5, 6 with the 1. And with the 2, you can go 1, 3, 3, 6, 6. So here my key for the data. If I have 3 line 2, it's 32. But here you can see that this data is roughly symmetric, possibly skewed a little bit to the right. Okay. If you wanted to find your median, you could find your middle number. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. So these two are in the middle. So your median in this case, you'd have to do 23 plus 26 divided by 2, which would give you what? 24.5. So your center in this case is 24.5. You could have also found the mean, but when it's skewed, you usually want to use the median for the value. Your range would be 41 minus 15, which is 26. And again, it's pretty tight together, so you probably have a little bit less variance. You might have some, but usually the variance is when you're comparing two different things of what has more and what has less. All right, so these data represent the responses of 20 female AP Statistics students to the question, how many pairs of shoes do you have? Construct a stem plot. Go for it. Here's mine. Whoops, this got a little cut off. So you can also have back-to-back stem and leaf plots. So for the boys, the leaves go that way, and for the girls, the leaves go that way. And that's okay. So here, if I wanted you to use the back-to-back stem and leaf plot to answer the following questions, see if you could do that. So the mean, median, mode for each set of data. Well, the mode's a little bit easier to pick out. It definitely for Mrs. B's, so Mrs. B's is over here. So it looks like your mode would be 88. And let's see, for Mrs. C's, it looks like your mode would be 95. So for the mean and the median, I'm going to go ahead and just put that into my list. So in list 1, I'm going to write 62, 70, 88, 88, 95, 98, 99, and 100. Now I can go stat, calc, one variable statistics, and I can see the mean, which is this guy, is going to be 87.5. Scroll down, and you'll see the median, and they put a MED, is going to equal 91.5. Okay, so let's go put stat, edit. Let's go put Mrs. C's class in our list 1. So nothing in the 60s, so I go 75, 76, 77, 82, 85, 89, 95, 95, 100. Okay, so again, I'm going to go over to stat, calc, one variable statistics. My mean here is 86. Scroll down, and your median is 85. All right, Histograms. Histograms are different than bar charts because in a bar chart you're using categorical data. In a histogram, you use quantitative data. So how to make a histogram, divide the range of data into equal widths, find the counts or frequencies or percents of the individuals in each class, and label and scale your axes, and then you can draw your histogram. So in these guys, the bars are touching, there's no separations. So kind of looking, the blue bar graph over here, you have the separation because you have categories. So the categories are for bar graphs. Quantitative data, so here you can see there's no separation. Quantitative data, you're going to do histograms. All right, make a histogram of the following data. The table represents the data on the percent of residents from each state who were born outside of the U.S. So see if you can do that. And this is what mine looks like. And again, you should label, label, label. So this would be at 5, 10, 15, 20, 25, 30. And these went by ones. You can see this goes all the way up to 20. So here, this is your class. This is your count, and whatever you want to give overall. So, born outside US would be great. Here's a little website if you'd like to go. This one shows several histograms of real-world data, and it's kind of fun to play around with this applet, see what you can discover. So in summary, for section 1.2, you can use dot plots, dim plots, histograms to show the distribution of quantitative variables. When examining any graph, look for the overall pattern, departures from the pattern, the shape, center, spread, outliers, and the variance. Okay. Some distributions have simple shapes such as symmetric or skewed. The number of major peaks is another aspect. When comparing distributions, be sure to discuss, again, shape, center, spread, possible outliers, and again, the variance. Don't forget that. How spread out that data is. Histograms are for quantitative data. Bar graphs are for categorical data. And use relative frequency histograms when comparing data sets of different sizes. All right, I'll see you in section 1.3 next.